In this video, we're going to be walking through an example for a large sample hypothesis test for comparing mu1 and mu2. So to do that, we're first going to set our alpha level. We're going to set alpha is equal to 0.05. And then to state our null hypothesis, h0 is the same for all these tests, which is our mu1 minus mu2 is equal to some d0 value. And in this case, we're going to set d0 equal to 0. And then for our alternative hypothesis, or HA, we're going to say our mu1 value minus mu2 does not equal our d0, or again, 0. So we're basically testing to see if mu1 and mu2 are different or the same. So for our test, we're going to need our test statistics. So we're going to find z is equal to our x1 bar minus our x2 bar, and that value minus d0. And then we divide all that by our sigma sub x1 bar minus x2 bar. If we carry out that formula and plug in some of our values, we get our 10 minus 13, all that minus 0, divided by our sigma sub x1 bar minus x2 bar, which we know from the previous videos is the square root of sigma 1 squared, which is 5, divided by n1, which is 50, and added to our sigma 2 squared, which is 7, divided by our n2, which is 40. And if we keep going with this, we get negative 3 minus 0 over the square root of 5 divided by 50 is 0.1, plus 7 divided by 40, which is 0.175. Keep going. We have our z is now equal to negative 3 over the square root of 0.1 plus 0.175 is 0.275, which gives us negative 3 over 0.524, which equals negative 5.7207. Now to actually test our hypothesis, we're going to need to find what our z value is when we're plugging it into our formula. So we plug in absolute value of z, which is equal to the absolute value of negative 5.7207, so 5.7207. And then we're going to compare that to our z sub alpha over 2. So we have z of alpha over 2, which is equal to our 1.960, because we have z of alpha is 0.05 again, so we have 1.960. And we're testing to see if this value is greater than. So if 5.7207 is greater than our 1.960, and since it is, we reject h0 and accept our HA. So basically we're testing to see if mu1 is equal to mu2, and after our test we determine that mu1 is in fact not equal to mu2, so we are accepting the fact that mu1 and mu2 are actually different values.